Hello everyone, I am Mrs.G.LOKESHWARI, Assistant Professor of Computer Science, A.D.M. College for Women, Autonomous, Nagapattinam. Now we will see the topic about data pre-processing in data mining and data warehousing. Data pre-processing, the data quality, major tasks in data pre-processing and data cleaning, data integration, data reduction. Data quality, why process the data? Measures for data quality, a multidimensional view. We are process the quality of the data. First, we accuracy of the data. The data is correct or wrong, accurate or not. We are find out the data is correct or wrong. Next one is completeness, not recorded, it is available of the data. Next one is consistency, some modified but some not dangling. The consistency is occurred in the data quality. The next one is timeliness, timely update the data. Next one is believability, how trustable the data are correct or not. Then interpretability, how easily the data can be understood. These are the quality of the data. Then major tasks in data pre-processing. The first step is data cleaning, second one is data integration, third one is data reduction, fourth one is data transformation and data discretization. First we see that data cleaning, fill in missing values, smooth noisy data, identify or remove outliers and resolve inconsistencies. Second one is data integration, the integration of multiple databases, the data cubes or data files, it consists of the data integration. The third one is data reduction. The data reduction, it consists of the three types: dimensional reduction, numericity reduction, data decompression. The fourth one is data transformation and data discretization. We include the topic about the normalization and the concept hierarchy generation. First we see the topic data cleaning. Data in the real world is dirty. Lots of potentiality incorrect data occurs in data cleaning. Example, instrument faculty, human or computer error, transmission error, these are the data or dirty data. Incomplete, lacking of attribute values, lacking of certain attributes of interest or containing only aggregate the data. For example, occupation equal to double quotes. The data is missing the data. We put the data occupation equal to assistant professor or he is an engineer. So something else we are putting the data. But we are not writing the place occupation equal to double quotes. It is an incomplete data. The next one is noisy data. It contains noise, errors and outlier of the data. Salary equal to double quotes minus 100. It is an error because the salary is the positive value plus then thousands of values occur in the put in the place of the salary. So it is a noisy data. Third one is inconsistent. What is meant by inconsistent? It is a discrepancy in codes on names. Sometimes the age equal to 42, birthday equal to 3/7/2010. But the 2010 to 2024, the age is 34. But we are putting age equal to 42. It is a discrepancy of the data. It occurs in duplicate the records of discrepancy. Then fourth one is intentional. Then distinguish the missing data. January 1 is everyone's birthday. It is not correct. So it is an inventional, that is used between the missing of data. Then next, incomplete, missing of data. The data is not always available. Example, many tuples have no recorded value for several attributes such as customer income in sales data. The missing data due to equipment malfunction, inconsistent with other recorded data and thus deleted. The data not entered due to misunderstanding. Certain data may not be considered important at the time of entry. The data is registered history or changes of the data. The missing data may need to be inferred. How to handle the missing data? Ignore the tuples. Usually, then when class label is missing, it is not effective when the percentage of missing values per attribute varies considerably. Fill in missing values manually, plus tedious plus infeasible. Fill in automatically with a global consistent, then global constant values, that is the attribute means. What is meant to be attribute means? For all samples belonging to the same class. For example, it is a smarter like this. The most probable value inference based such as that is Bayesian formula or decision tree. Noisy data, noise. The random error or variance in a measured variable. Incorrect attribute values may be due to faulty data collection of instruments, data entry problems, data transmission problems, technology limitations, inconsistency in naming convention. Other data problems which require data cleaning is duplicate records, incomplete data, inconsistent data. Then, how to handle the noisy data? There are the four types of problems occurred in the noisy data. The first one is binning, regression, clustering, combined computer and human inspection. Binning. First sort the data and partition into bins. Then one can smooth by bin means smooth by bin median, smooth by bin boundaries, etc. It is called the binning values. Second one is regression. Smooth by fitting the data into regression function. Third one is clustering. It detects outliers and remove the outliers. Then combined computer and human inspection. It detects suspicious values and check by human. For example, deal with possible outliers. Then data cleaning as a process. Then data discrepancy detection and data migration and integration. First one is data discrepancy detection. Use the metadata. For example, domain, range, dependency, then distribution. Check the field overloading. Then check the uniqueness rule, then consecutive rule and a null rule. Use the commercial tools, that is data scrubbing and data auditing. Data scrubbing, use the simple domain knowledge. For example, postal code, spell check to detect the errors and make the corrections. Data auditing, by analyzing the data to discover the rules and the relationships to detect, that is the violators. For example, correlation and clustering to find outliers. Data migration and integration. Data migration tools allow transformation to be specified, that is ETL transaction, that is extraction, E for extraction, T for transformation, L for loading, that is ETL tools. It allows the user to specify transformations through a graphical user interface. Integration of the two process, the iterative and the interactive, that is the part that deals in the integration process. Data integration. It combines the data from multiple sources into a coherent store. The schema integration, for example, A dot customer ID equal to B dot customer ID hash. The integrated metadata from different sources, they include the schema integrations. The entity identification problem occurred in data integration. Identity real-world entities from multiple data sources, for example, Bill Clinton equal to William Clinton. It is detecting and resolving data value conflict. For the same real-world entity, the attribute values from different sources are different. The possible reasons, the different representation, different scale, for example, metric versus British units. Handling the redundancy in data integration. The redundant data, that is called the repeated data. The redundant data occur often when integration of multiple databases, that is object identification and derivable data. Object identification, the same attribute or object may have different names and different databases. The derivable data means one attribute may be a derived attribute in another table, for example, annual revenue. The redundant attributes may be able to be detected by correlation analysis and covariation analysis. It is careful integration of the data from multiple sources may help reduce, avoid redundancies and inconsistencies and improve mining speed and quality. Then correlation analysis applied in the nominal data, that is the chi-square test is applied in the correlation analysis. The large x-squared value, more likely the variable are related. The cells that contribute the most of us x-squared values are those whose actual count is very different from the expected count. The correlation does not imply causality. For example, a hash of hospitals and hash of car theft in the city are correlated. Both are causally linked to the third variable is population. The hospitals are most of us raised and increased in the population. The car theft also raised and increased in the population. The hospital and car theft are related to, that is the both are causally linked to the variable. The third variable is the population. That is occurred in the correlation, does not imply causality. The chi-square population example, the play chess, non-play chess and sums. The life science functions 250, 200, the sum of the value is 450. Not like the science fiction, that is 50 plus 1000, that is the sum of the value is 1050. Then sum of the values, play chess is 300, then non-play chess is 1200 and the sum of the value is 1500. In the chi-square test, the calculation numbers in parentheses are expected count calculated based on the data distribution in the two categories, that is play chess and non-play chess. It shows that like science fiction and play chess are correlated in the group. Then correlation analysis numerical data. The correlation coefficient, also called Pearson product moment coefficient, R A comma B equal to summation I equal to 1 to n A minus A bar Bi minus B bar divided by n minus 1 sigma A sigma B equal to summation I equal to 1 to n A Bi minus n A B bar divided by n minus 1 sigma A then sigma B, where n is the number of pupils, A bar and B bar are the respective means of A and B, then sigma A and sigma B are the respective standard deviation of A and B. Summation A Bi is the sum of the AB cross products. We test the function if R A comma B greater than 0. A and B are possibly correlated. A's values increases with B's values. The higher, the stronger our correlation. The next one is R A comma B equal to 0. It is independent. Then R A B less than 0. It is a negativity correlated. The correlation coefficient views as a linear relationship. The correlation measures the linear relationship between the objects. It computes the correlation. We standardize the objects A and B and then take their dot product. A dash K equal to AK minus mean of A divided by standard deviation, that is STD of A. Then B dash K equal to BK minus mean of B divided by then standard of B. Correlation A comma B equal to A dash dot B dash. These are the formulas used in covariance of correlations. Next topic is covariance numeric data. The covariance is similar to the correlation. Using the formula covariance A comma B equal to E of A minus A bar B minus B bar equal to summation I equal to 1 to n A minus A bar into BI minus B bar divided by n. The correlation coefficient occur in R A comma B equal to covariation A comma B divided by sigma A and sigma B, where n is the number of pupils, A bar and B bar are the respective mean are expected values of A and B. Then sigma A and sigma B are the respective standard deviation of A and B. There are the types of covariance. Positive covariance. If covariance A comma B greater than 0, then A and B both tend to be larger than their expected values. That is a negative covariance. Then covariance A comma B less than 0. If A is larger than its expected value, B is likely to be smaller than its expected value. That is the independence covariance. Covariance A comma B equal to 0, but the converse is not true. Some pairs of random variables may have a covariance of 0, but are not independent only under some additional assumptions. The data flow, multivariate, normal distributions. Thus, the covariance of 0 simply independence. Then, for example, it can be simplified in computation. Suppose two stocks A and B have the following values in one week: 2, 5, 3, 8, 5, 10, 4, 11, and 6, 14. The question is, if the stocks are affected by the same industry trends, will their prices rise or fall together? First, we put the values E comma A of A equal to that is X value only we add and divided by number of items. So 2 plus 3 plus 5 plus 4 plus 6 divided by 5 equals to 25 by 5. That is the value is 4. Then same conditions A of B equal to that is the value of B, we put in the value then divided by number of items. 5 plus 8 plus 10 plus 11 plus 14 divided by 5 equal to 48 by 5, that is a 9.6. The covariance of A comma B using the formula A of A dot B minus A bar B bar. Then 2 into 5 plus 3 into 8 plus 5 into 10 plus 4 into 11 16 into 14 divided by 5 minus 4 into 9.6 equal to 4 is the value of covariance of A comma B using the formula covariance of A comma B equal to summation I equal to 1 to n A minus A bar B minus B bar divided by n. Thus, A and B rise together since covariance A, B greater than 0. Then fourth one is data reduction strategies. Data reduction means reduce the representation of the data set that is much smaller in volume but yet produce the same, almost the same analysis of analytical results. Why data are reduced? The database or data warehouse may store terabytes of data. The complex data analysis may take a very long time to run under the complete data set. The data reduction strategies are dimensionality reduction. It removes unimportant attributes using the wavelet transformation, principal component analysis, then future subset selection, future creation. The numericity reduction, for simply call it, that is their data reduction. Using the methods, the regression and log linear models, histogram, clustering, sampling, data cube aggregation. The last one is data compression. In data reduction, dimensionality reduction, that is the cause of dimensionality. When dimensionality increases, the data becomes increasingly sparse. The density and the distance between points, which is critical or clustering outlier analysis, become less meaningful. The possible combination of subspaces will grow exponentially. Dimensionality reduction avoid the curse of dimensionality, help eliminate irrelevant features and reduce noise. Reduce time and space required in data mining. It allows easier visualization. The next one is dimensionality reduction techniques. There is a wavelet transform, then principal component analysis, supervised and nonlinear techniques are followed in that method. The mapping data to a new space. There are two transforms are applied in the picture. The Fourier transform and the wavelet transform, the two sine waves and the two bind waves plus noisy. Then third one is frequency occurred in the mapping data to a new space. What is wavelet transform? Decompose a signal into different frequency subbands applicable to n-dimensional signals. The data are transformed to preserve relative distance between objects at a different level of resolution. Allow natural clusters to become more distinguishable. Used to image compression, we use the wavelet transform techniques. In wavelet transform techniques, discrete wavelet transform for linear signal processing. That is a multi-resolution analysis. It compressed approximation. It stores only a small fraction of the strongest wavelet coefficient. Similarly, to discrete Fourier transform, there is DFT, but better lossy compression technique, it is localized in the space. These are the methods used in the wavelet transform. The length is denoted as L, must be an integer, that is power of 2. Each transformation has two functions, that is smoothing and difference. Applies to pass of data, the resulting in two set of data lengths, that is L by 2. Applies two functions recursively until reaches the desired length. The wavelet. What is meant by wavelet decomposition? Wavelets are a mathematical tool for space efficient hierarchical decomposition of functions. That is S equal to 22023544. It can be transformed to, that is S 2 3 by 4 minus 1 1 by 4 1 by 2 0 0 minus 1 minus 1 0. This is the wavelet decomposition using the mathematical tool. The value is S equal to 2 3 by 4 minus 1 1 by 4 1 by 2 0 0 minus 1 minus 1 0. This is the compression. The many small detail coefficients can be replaced by zeros. Then only the significant coefficients are retained as the resolutions, average and detail coefficients. The resolution is 8421. The average value is put in the data S equal to 22023544. Next in the 4, then 2144, then 2 is 1 1 by 2 comma 4. Then the last one is 1 into 3 by 4. The detailed coefficient values occur in the third part, that is 0, minus 1, minus 1, 0, 1 by 2, 0, then minus 1, 1 by 4. These are the value in mathematical tools occur in wavelet transformation and decompression. The next one is Hare wavelet coefficient. Hierarchical decomposition of structure using the tree structure. We are using the coefficient format is Hare wavelet coefficient, the original frequency distribution of in the diagram. The wavelet transform use heart-shaped filters. It emphasizes the region where point is clustered. suppress the weaker information in their boundaries, effective removal of outliers. It is insensitive of noise, insensitive of input order, multiple resolution. It detects arbitrary shaped clusters at different scales. Efficiently, the complexity of data is order of n. That is only applicable to low dimensional data. The principles of component analysis. Find a projection that captures the largest amount of variation in data. The original data are projected into a much smaller space, resulting in dimensional reduction. We find that eigenvectors of the covariance matrix and these eigenvectors define the new space. In this diagram, x1, x2, then e, find the projection of capture the large amount of variation of the data. Given n data vectors from n dimensions, find k less than or equal to n, the orthogonal vectors, the principal components that can be best used to represent the data. Normalize input data. Each attribute falls within the same range. Then compute k orthonormal unit vectors, that is principal amount of components. Each input data vector is a linear combination of the k principal component of vectors. The principal components are sorted in order to decreasing the significance of strength. Since the components are stored, sorted, the size of the data can be reduced by eliminating the weak components. Those with low variance using the strongest principal components, the possibility to reconstruct a good approximation of the original data. Works for numeric data only. The attribute subset selection. In another way, to reduce dimensionality of data, the redundant attributes duplicate much or all of the information contained in one or more other objects. For example, purchase price of a product and the amount of sales tax paid. Irrelevant attributes contain no information that is useful for the data mining, the task at the hand. For example, student ID is often irrelevant to the task of predicting students of GPA. The next one is heuristic search in attribute selection. We use the formula. There are the 2 power d possible attribute combination of d attributes. Typically, the heuristic attribute of selection method, the best single attribute, best stepwise future, stepwise attribute elimination, then best combined attribute selection and elimination, and optimal branch and bound. The best single attribute under the attribute independence assumption, choose by significance test. Best stepwise future selection, the best single attribute is picked first. The next best attribute conditions to the first, then next, etc. It is the stepwise attribute elimination. Repeatedly eliminate the worst attribute. The best combined attribute selection and elimination. The optimal branch and bound use attribute elimination and backtracking methods. Then attribute creation. It is the future generation. Create the new attributes that can capture the important information in a data set more effectively than the original ones. There are the 3 general methodologies used in attribute creation. The first one is attribute extraction, mapping data to a new space. That is called data reduction in the previous topic. Then attribute construction. First one is attribute extraction. It is the domain specific method. The mapping data to a new space. For example, Fourier transformation, wavelet transformation, then manifold approaches. Not covered in the mapping data to a new space. Attribute construction, combining the features of the data, that is the data discretization. Data reduction, the second type is numericity reduction. A reduce of data volume by choosing alternative smaller forms of data representation. That is a parametric method and a non-parametric method. There are the 2 types of numericity reduction. The parametric method using the regression is called assume the data, fix some model, estimate the model parameter, store only the parameters and discard the data. These are the steps followed in parametric method. For example, the log linear models obtain value at a point in empty space at the product on appropriate marginal subspaces. The second one is non-parametric methods. Do not assume the models. The major families are histograms, clustering, and sampling. The parametric data reduction, the regression, and the log linear models are included in the method. Linear regression, multiple regression, and log linear model. Linear regression, the data modeled to fit in a straight line, often uses the least square method to fit in the line. Multiple regression allows a response variable y to be modeled as a linear function or multifunctional feature vector. The third one is a log linear model, approximate discrete multidimensional probability distribution. Then regression analysis. The regression analysis is a collective name for techniques for the modeling and analysis of numeric data. It consists of values depend the variables. It also called the response variables or measurement. And one of more independent variables is the explanatory variable or the predicators. The parameters are assigned to give a best fit to the data. Most commonly, the best fit is evaluated by using the least squares method, but otherwise also has been used in the diagram. The user uses the prediction method. In the diagram, we select the hypothesis testing and the modeling causal relationships. In regression analysis, the log linear models using the linear regression, multiple regression and the log linear models using the formula y equal to wx plus b. Two regression coefficients w and b. It specifies the line and are to be estimated by using the data at the hand. Using the least square correlation criterion to be known as y1, y2, etc. and x1, x2, etc. Second one is multiple regression. Y equal to b0 plus b1 x1 plus b2 x2. These are many nonlinear functions. It can be transformed into the above linear regression formation. Then log linear models, it approximates discrete multidimensional probability distribution. It estimates the probability of each point in multidimensional space for a set of discretized attributes and based on the smaller set of dimensional combinations. It is useful for dimensionality reduction and data smoothing. In the histogram analysis, it divided the data into buckets and stored the data in some of the buckets. It is partitioned in equals. First one is equal width and equal frequency. Equal width, the equal bucket range is equal values of the width. Then equal frequency, the data is frequently goes to the equal depth and the data. It is divided into buckets of storage of average and average of equal frequency. The next one is clustering. The partition data set is clustered based on similarity and stored clustered representation. It is the centroid and diameter only. It can be very effective if data is clustered, but not if data is mirrored. You can have hierarchical clustering and be stored in multidimensional index tree structure. There are many choices of clustering definitions and clustering algorithms used in the format of clustering. Cluster analysis, we used in the cluster analysis. The next topic is sampling. Sampling, obtaining a small sample, S represents the sampling, the whole data is N. Allow a mining algorithm to run in complexity that is potentially sublinear on the size of the data. What are the key principles using the sampling? Or a simple random sampling may have very poor performance in the presence of skewing method. It develops adaptive sampling methods, for example, stratified sampling. Then types of sampling: simple random sampling, sampling without replacement, sampling with replacement, then stratified sampling. Simple random sampling, there is an equal probability of selecting any particular item, that is called simple random sampling. Second one is sampling without replacement. Once an object is selected, it is removed from the population. Sampling with replacement, that a selected object is not removed from the population. The next one is stratified sampling. The partition the data set and draw sample from each partition proportionally approximate the same percentage of the data used in conjunction with skewed data. Thank you.